Welcome to Space Time with Dave. I am Dave, and I wanted to start a series of videos. I want to do like a companion video for each one of my deep space astrophotography images. The reason for that is to help communicate better what it is you're looking at. And the thing about these deep sky images is it can be very difficult to grasp what the heck it is. I mean, they look very beautiful, and there's these great colors, but it's kind of abstract, and without some idea of scale and position, or what the heck it is, it just is kind of a pretty picture. If I showed you a bird, a picture of a bird, you'd probably you'd see that bird, and you've seen birds before, so you have a general idea of yeah, birds are somewhere between that big, and well, maybe they're an eagle is really big, but it's it's not the size of a house, or it's not it's obviously not on the moon. So but a lot of these images, unless you study astronomy, can be really hard to understand what the heck they are. And honestly, it's something that took me a long time to get a grasp on what the heck it is I'm seeing. Today, the first image that I want to show off is my shot of the Eagle Nebula M16, and here it is. This is one of my all-time favorite objects. It's really beautiful, amazing color, amazing detail. I shot this with my trusty Canon 7D Mark II and my 8-inch Orion Newtonian telescope, which has a focal length of about 800 millimeters. It's about 2 hours total of integration time, and I shot this at the Grandview Campground in the White Mountains of California last summer, so June of 2016. So the Eagle Nebula, like a lot of these objects, got their name even before photography existed. So it's kind of based on what it looks like in a telescope. So this is the this great website here, a Deep Sky Watch, has all these illustrations. So this is a drawing that someone did of the Eagle Nebula, what it looked like to them through their 8-inch telescope. So not nearly as remarkable as the long exposure image, but you can kind of see it. You kind of see this eagle, like this is the head of the eagle here, and this is kind of a wing, and that's a wing, and maybe he's kind of looking to the side or something, and I don't know. Different people see it differently. I guess I kind of see an eagle in there. It's a pretty faint object actually to actually try to observe. So the really cool thing about the Eagle Nebula is that it is the location of probably one of the most famous astrophotography images of all time, and that is the Hubble Space Telescope image, The Pillars of Creation. And so I have a picture of the pillars here. So this is the original 1995 image from the Hubble Space Telescope, and this was kind of one of the first real good images to come out of this telescope. Absolutely beautiful detail in these dust clouds. So if you look at my image, this is the location of the pillars here, and so you can see there's these long sort of dust fingers. So this is gas and dust, and that's what we're seeing in the Hubble telescope image, but just in much finer detail. Now the colors are different, and I really want to talk about the colors because that's a really interesting subject, but that's worthy of a whole separate video, so maybe next time. So this is the original 1995 image, and the Hubble Space Telescope has been serviced several times since going up, and I believe the last service mission was 2009. Someone correct me on that if I'm wrong. And they installed a new camera, and this is the new image of the Pillars of Creation. This is outstanding. Look at the detail in here. We zoom way in. I mean, this is a super high resolution image, and I encourage you to, I'm going to put a link to download this image, and just download this yourself and just scroll around and look at these fantastic detail, these fantastic structures. So this is an active star forming region, and go back to my image. So what we're seeing here is brand new stars that are forming from all this gas and dust. And in the Hubble image, we can actually see, you zoom way in, you look at these little globules here, we can actually see new stars forming right from this big glob of gas and dust. So one of the things I always like to show people is, you know, you look at my image and it's really nice. I'm really happy with it. This is about what about $5,000 worth of equipment will get you, and then, you know, this is what about $5 billion worth of equipment will get you. So maybe if I get enough YouTube subscribers, I can purchase my own space telescope and get you more images like this. Okay, so the next thing I want to show is the location of the Eagle Nebula. And to do that, I have this excellent piece of software called Stellarium. Stellarium is freeware. I'm going to put a link to download that. I strongly encourage you to install Stellarium and just play around with it. And it has all these cool tools and things you can show different objects, and it's a really great tool for just learning the night sky and where things are and how things move across the sky at night. I use Stellarium for planning out my astrophotography ventures. Before I go out, I want to be prepared. I want to make sure I have the the targets in mind that I want to shoot. Oftentimes there's no internet, no cell reception where we go camping, so I need to know ahead of time what I'm going to look at. Right now I've got it set to midsummer July, and it's almost midnight the time here. So, and you can change the time and what it shows. So, and I'm looking southeast a bit, and you can see the Milky Way here. This is the Milky Way, and we're going to look towards the constellation of Sagittarius. So this is the Teapot Sagittarius, and this is bright enough that you can see, even in a light polluted area, you should be able to see the Teapot. So we're going to go up just a little bit to the constellation Scutum, the Shield. You can see these things start to show up. So there's a lot of nebulae in this region. You can see the pink areas, and the reason for that is we're looking right at the galactic core. We're looking at the center of the galaxy, where there's going to be the highest concentration of stuff: stars, gas and dust, nebulae. All this stuff is going to be concentrated, at the galactic disk, but particularly at the core, right? So that's where we're looking, and but right now we're looking at the Eagle Nebula, which I keep zooming in, and there it is. And so this is to scale, and Stellarium's image, kind of looks rather like mine. And so if I just I can kind of like click on one of these stars, and it'll put a little target there. And as I zoom out, now you can see the part of sky that we're looking at. Another interesting thing to note about this region and about my image is the dark area. So the dark area is not empty space here. What we're actually looking at is you're looking into the dust cloud of our galaxy. You're looking into a big dark cloud. And so when you look at Stellarium, you can see this cloud right along here. I mean, if you were shooting an object way out over here, it would be empty space. But here you can see everything that's dark here is not empty space. That's actually dust and gas. To help get a better idea of that, let's look at a picture of a galaxy. So here's my picture of Andromeda, our nearest galactic neighbor, which deserves a video all on its own. But take a look you can see the dust bands in here, these dust lines, these spiral arms. Imagine you were on a planet orbiting, maybe like that star there, and looking in the direction of the galactic center. So what you would see is a wall of dust, just like what you see in Stellarium here. Yeah, so all the black in here is not empty space, it's actually a big wall of dust. Now, yes, the density is really, really low. It's not like it's definitely still a vacuum. It's not like, it's not like being on the Earth where you have, oxygen that you can breathe. But effectively, it is just a big wall of dust. So the way to look at these images is this is really kind of a hole that's been like scooped out, or more accurately, the newly formed stars in the region have condensed from that big cloud of material. So to illustrate that, I have a piece of white cake here. So imagine this cake. Okay. So the cake is kind of low density. It's kind of fluffy, right? So now I can just kind of take a big chunk out of it like that. I eat it. And now there's a big hole there. So instead of eating it, if you took all that cake and imagine just crumping it down, smashing it down to the size of a star. So that's what you're seeing there. So I hope that analogy makes sense. That what you're looking at is really more of a hole in a big cloud than a big glowing cloud of pink dust. So why the colors? Why the pink? Why is my image pink and the Hubble Space Telescope image this combination of greens and blues and yellows? That is a topic for another episode, and it's a subject that I'm really interested in. It's called fluorescence, and we're going to get to that because I really want to. So I hope you stick around. I hope you'll subscribe. I hope you'll watch all of these videos because I really like talking about this stuff, and I think it'll be pretty fun. So stay tuned, and you guys just have yourselves a wonderful day.